Junior Cycle Higher Level 2014 June SEC paper 1 question 4. This is an algebra question and it's looking for you to do some factorizing. Don't forget, a factor is something that goes into a large number. So the factors of 6 is 2 and 3, because 6 can be divided by 2 and 6 can be divided by 3. Also 1 and 6 are factors of 6. So here with algebra, it's about what can you divide the expression by, and so it divides evenly as such. Or you could say to yourself what two things multiply together to make the algebra expression. Those two things would be considered to be factors. So for this question, we have an expression involving numbers A, B, C, several different letters there. And you've got even a squared term, a squared, which is obviously a times a. So when you have four terms, generally speaking, the way you would approach the question is to take a pairing. So you can take these two as a pair, and then separately you take the other two as a pair, and you see whether there's a common factor. Now, if you can't see anything, the alternative is you could take another pairing. So you take these two items, 9a squared and 12ac, and separately take these two terms. Lastly, as a final sort of set of pairings, you could take these two together and then these two together. So, but I mean, it's a case of just seeing something that you see there's a connection. So for me, I'm looking at these first two terms, and I can see they both have a 9 and 6. And 3 is a common factor, and also we've got a squared and ab. So I'm looking at these two terms, and I see that 3a is a common factor of those first two terms. And so to bring that common factor out, I get, to complement it, I have 3a minus 2b. What I've done effectively is I'm dividing 9a squared by 3a, and I get 3a, and I'm dividing minus 6ab by 3a, and I'm getting minus 2b. Likewise, I do the same process with the second pairing. These two terms, I try and look for something that is common to both. Well, I see that 12 with 12 and 8, 4 is a common factor, and separately I can see c is a common factor. So I can bring 4c outside as a common factor. So 4c, and inside the brackets I'm going to have whatever I would multiply together with 4c to get 12ac, that would be 3a, and what would I multiply 4c by to get minus 8bc? Well, I'd multiply by minus 2b. Now, I'm not finished yet. What you should notice, and generally speaking they'll set these questions up such this what happens, I've actually got what's inside the brackets is actually the same expression. So I have 3a times by this expression, and I have 4c times by this expression. Effectively what I've got is I've got a common factor. This, what's inside the brackets, is a common factor of both these two terms, these sections. So I'm looking at these two terms here, and those two terms both have got a factor of 3a minus 2b. So I can say to myself, right, 3a minus 2b is a common factor. And bring that outside, and inside brackets I can write whatever they are multiplied by. So in this case it's 3a plus 4c. And that expression has been fully factorized. Moving on to part B. We've got a very special expression here. This is what you need to notice and spot is you've got what's called difference of two squares. So difference means subtraction, and I'm subtracting one square from another square, giving the two squares. So 9x squared, we should realise that that's 3x all squared, and the minus 16y squared, well 16 again is a square number, and we have 4y all squared. Now, difference of two squares, the key rule is so a squared minus b squared is equal to the product of a minus b times by a plus b. So in this instance, I suppose my a is 3x and my b is 4y. And suffice to say, when I use this rule, I can use it straight away. I don't need to show any workings at all. I literally just say, well, I've got 3x minus 4y and I've got 3x plus 4y. That's basically what's going on. Whatever these two things I've got that are squared, I'm going to say one take away the other, and then one add the other. That's what I have. And that's fully factorized. Moving on to the last question, part C. Again, we're asked to use factors. That's basically meaning, can you factorize this expression? So we've got a fraction. Can we factorize the top, the numerator, and can we factorize the bottom? And it's asking us to simplify. So what I'm suspecting is that there'll be a factor on the top and the factor on the bottom that can cancel out. So let's go through the process of factorizing. So let's first off deal with my numerator. It's 2x squared plus 4x. And the common factor is 2x. So we have 2x multiplied by x plus 2. Y, very quickly, you see that 2 is a common factor of both 2 and 4, and x is a common factor of x squared and x. So that's why I have 2x outside, and so what do I multiply by 2x to get 2x squared? I multiply by x. And what do I multiply by 2x to get plus 4x, which is plus 2? So that's the numerator. And now we want to concentrate on the denominator. Now, the denominator you'll see is a full trinomial quadratic, so we have to go through the full factorizing process. So what two numbers multiply together to make minus 12 and add together to make positive 1? Well, in terms of factors, we've got 1 and 12, where one of them is positive, one of them is negative. We've got 2 and 6, where one is positive, one is negative. And lastly, we've got 3 and 4, where one is positive. And if we think about it, which pair adds together to make 1? It's minus 3 and 4, so I can expand the x term in order to then factorize. The first factor of the first two terms is x, and the factor of the last two terms is 2. We know we've done something right when we see that the two brackets are the same. We have a common factor of 2x minus 3, and what is multiplied by that is x plus 2. So let's put that up as my denominator. 2x minus 3, x plus 2. So our last step, in terms of simplifying, we notice that there's a factor on the top and the bottom that's the same. Therefore, we are allowed to cancel them out. It's basically they cancel each other out. Multiply by x plus 2 and divide by x plus 2, they cancel out. And what we're left with is 2x on the top in the numerator and 2x minus 3 in the denominator. Before I finish, very quickly, please do never think that you can just do cancelling or simplifying by just seeing, oh, the same thing, top and bottom, therefore I can cancel it. And so in this case you get something like 1 over minus 3. Same here. You're not allowed to cancel 2x squared and 2x squared because they're not common factors. They happen to be terms in the top and the bottom that are the same, but they are not common factors. You can only cancel when you actually have a common factor. This idea where you've got something that's multiplied by maybe another factor on the top, and likewise in the denominator you've got the same factor multiplied by another factor. And that's the only reason why I can cancel those, because it's in a factorized form. The two are multiplied together. I can't do any cancelling when they're just added together. I can only do it when it's multiplied together.